Alright, today is 2.6. We're going to be covering proving lines are parallel. Basically, it's the exact same thing we covered the day before on 2.5, but now we're using the converse of those statements. So right here, this is something kind of interesting. Every smiley face is congruent, and every blue and red slash dot are congruent when we have two pairs of intersecting lines. This is something you may want to know. It might help you on a test question. If you see two sets of intersecting parallel lines, you'll know that those angles are all congruent. So if we talk about the corresponding angle converse, before I would give you two parallel lines, and then from that we knew that those two angles were congruent because of corresponding angles. Well, now we're working backwards. If you have a setup like this where there's two lines cut by a transversal, and you know that angle 1 and 2 are congruent, then you know that the two lines being cut are parallel. And here it says J and K, but they're not really labeled that way. So that's corresponding angle converse. If I give you those angles are congruent, you can then tell me that they're parallel. There's only 6 reasons today we're talking about, and so let's go through them quick. If angle 3 is congruent to angle 4, again, this is alternate interior angles. So instead of giving you parallel, I give you two angles are congruent, and you tell me what lines are parallel. Consecutive interior. Now this one's not about congruency. Remember, consecutive interior, CIAs are the government, they're the weirdos. They're different. They add to 180. They're not congruent. They add to 180. And if I give you 5 and 6, and I tell you that they add to 180, then you know that the two lines are parallel. We also have alternate exterior angle converse. We've already talked about this before. If 7 and 8 are congruent, then you know that the two lines being cut by the transversal are parallel. Alright, here's a new one for you. This is basically an extension of the transitive property. If P is parallel to Q and Q is parallel to R, then P is parallel to R. So if you're good with the transitive property, remember how we said the red marker equals the blue marker and the blue marker equals the black marker? Then we can get rid of the blue markers in the middle and just say red is equal to black. Here we're saying P parallel Q, Q parallel R. Well, let's just get rid of that Q in the middle, and we're left with P parallel R. And this is an extension of the corresponding angle converse. Basically, if two lines are perpendicular to the same line, then they're parallel. Which is basically saying, if you look right here, this 90-degree angle corresponds to this 90-degree angle, and therefore they are parallel. So you can look at it either way. Let's keep cruising along. These are right here, all 6. The 6 ways you can prove two lines are parallel. Now remember, this is an extension of the transitive property, and this one here is an extension of the, I guess you could say any one of the other 4, but I think of it mostly as consecutive. But they're going to be on your cheat sheet for the test, so get used to that. Also, here we have 6. This is the test hint. You need to know what these are and how to tell me what lines are parallel. So here's an example. I've got 3 lines, no information about the lines whatsoever, but if I tell you that 52 and 52 are equal to each other, which is obvious, then we have to be able to recognize that it's the alternate interior angles converse that allows us to say J and K are parallel, and that's right up here. Why can we conclude that J and K are parallel? Well, because of the alternate interior angle converse. Right here, if J is perpendicular to N and K is perpendicular to N, what postular theorem allows you to conclude that J is parallel to K? Well, that looks like the two perpendiculars, number 6, if you will. Two lines are perpendicular to the same line. Okay, how about this one? This has got a lot of information on it. We don't know anything about the lines, but we do see here these red lines mean that 1 and 2 are congruent. That's what those little curved arcs mean. And since this equals 90, then 1 plus 2 must equal 90. And since they have to equal each other, we know that 1 and 2 equals 45. Now we look at 135 plus 4 forms a linear pair, so we know that angle 4 plus 135 has to equal 180 degrees, which means that angle 4 has to equal 45 degrees. When we look at those 4 angles, all of them are 45 degrees for different reasons. This one's 45 because of a linear pair. This one is 45 because they're angle bisected and they have to add to 90. Alright, But regardless, if we look at this 45-degree angle and this 45-degree angle, then we can then say that either corresponding angles, which is my preferred method, you see 45 and 45, they're corresponding angles, so that means that J and K has to be parallel. But if you notice, angle 3 is 90 and angle 2 is 45. So together they make 135 degrees, which is alternate exterior to this 135. So either one of those will work as far as proving those two lines are parallel. Alright, this is just in your notes. So these in your notes, make sure you understand. Here we've got some information. Not a whole lot about lines or anything, but I want to show that J and H are parallel. So if I come over here and I grab my pen, that means that we already talked about this as being the blues, right? I'm going to draw this one as well. It's a terrible blue line. There you go, blue and blue. And then we always talked about it being cut by a red. If I use this as my transversal, I only have one angle. I don't have enough information right now to really talk about J and H being parallel. If I use this one as my transversal, then I can see, hey, this X and this 180 minus X makes consecutive interior angles. And since 180 minus X plus X equals 180, we can then conclude, get rid of those, that it's the consecutive interior angle converse. So let me leave that up there for a little bit longer. Pause the video if you need to write it down, but it's consecutive interior angles, or CIA converse. Okay, right here. We're looking for a reason why P is parallel to Q. Now I come over here, and I say P and Q are my blues, and I'm looking for a red transversal. If I draw it here, I don't have enough information. All I have is the 80. But if I draw it here, I can see, hey, I got this red arc here, and this red arc here telling me that they're congruent. And then I can say that it's because of corresponding angles. Corresponding angle converse is why those two are parallel. Now I'm looking at R and Q. So I grab Q, draw blue, R, draw blue. Now I gotta pick which transversal. If I pick this one, I don't have any information. I don't have sufficient information. And if I pick this one here, I can see, hey, look, 100 plus 80, that makes 180, and that makes it have to be a CIA situation. Those darn governments. Okay. We say consecutive interior angles, CIAs, and it's the converse because we're proving. Now, P is parallel to R. Interesting. I've just shown that P is parallel to Q. P is parallel to Q, and I've also shown that Q is parallel to R. I think about this really hard. I look at one of these 6 reasons down here. One of these 6 reasons has got to be good enough to say that P is parallel to R. And I look through it and I say, hey, look, if two lines are parallel to the same line, then they're parallel. So I put that in there. I say, get rid of those lines, and I say, notice that Q and the Q right there. P is parallel to Q and R is parallel. That's the transitive property. We can drop off the Q's and we're just left with R. Instead of saying transitive property, we can talk about this additional proof, saying two lines are parallel to the same line, then they are parallel. Now, S and P, it says here we don't have any angle measures, and I want to point this out one step before. So right here, we're looking to try and prove that S and P are parallel. It's right here. I know the symbol says not parallel right there, but go with me on this. If I try and say S and T are parallel, they're the blue lines, and I draw a red transversal here, I only have one angle. I don't have any information about any other angles, just that 100. That's not enough information. So come here, look at this P. Still, I only have this one angle right here. I don't have enough information. And then I look at Q, and sure, I've got this 80, and sure, I've got this congruent symbol, but they're not linked in any way. So I don't have any information to be able to say S and P are parallel, which is why we say we don't have any angle measure. We don't have enough information about S and T. Right here, A is parallel to B. Well, if I look at this, A is B, A and parallel. I draw a blue line for A, a blue line for B. Now I'm looking for a transversal. It's going to give me enough information. C, I only have one angle. Darn it. E, I don't have any angle for E. Gee, that's worthless. D, okay, now I've got, this is my transversal. I can see that this blue situation right here forms a CIA situation going on right. I say, alright, then the answer would be CIA. I noticed those two there. Now this one, I'm drew in green for you, but I want you to remember the best way to do it is if I say C and D, I better draw a C in blue and D in blue and try and find a transversal that's going to work for us. B does not give me enough information. I don't have any angles up here and I don't have any angles down here. I don't have any information off of B. So I have to use A as my transversal, and once I do that, I can see that those two angles are perpendicular. Okay, and when I say that, I say that they're both perpendicular to the same line, which again is an extension of those other properties, but you got to think about it as perpendicular. Alright, now the next one. Same reason, we don't have enough information about E. Notice how this is E and this is E? There's no angles, there's no information about line E. We don't know anything about it. So we cannot talk about E as being parallel. So, right here, next one. This is a little bit of an algebra review, but we're going back to yesterday's material, 2.5. Notice how I give you these arrows. Those arrows mean parallel. Well, I told you they're parallel, and now I'm asking you what would be my reasoning for saying that those two values are equal to each other. I notice 3x occupies this location, and 105 is this location. Well, I'd say, geez, those look like they correspond to the same location. So my answer, quite literally, is corresponding angles. And I say x equals 33, well I just had to divide by 3 across, and I get x equals 33. That's the division property of equality. Now if I look at here, I say 5y and 105 equals 180. And again, I come over and I say, hey, look, these make the little box. Call those a CIA. That's my reason. And then I do some algebra. I subtract, I divide, and I get my answer. That's how we use this information to solve questions. Alright, gotta go quick. Running out of time. I'm only about 3 minutes left. So make sure you get these down in your notes. If you notice that we do alternate interior angles from 120 to x plus x. Also, we can use the x and the y as CIAs to get our answers down. So just make sure you get these in your notes. Right here we talk about alternate interior angles twice over. Right here we talk about 4x lines up with 52, and 32 lines up with 3y plus 8 very nicely. Talk about what about z. Well, z we can use CIAs with d plus 4 plus 32. All of those angles together makes 180. And we do a little bit of algebra, and we solve it. Feel free to pause them right here if you need to write this down in your notes. Alright, right here we've got a little bit of an interesting situation going on. I say 5x plus 13 equals 6x plus 1. Well, that's corresponding angles. I do some algebra, I find out x equals 1, or 12. Next one. Those two add up to be 180 because they're consecutive interior angles. Again, I do more substitution, more algebra, and I find out y equals 13. Next one here, I see w plus 120 equals 180. That's a linear pair. And then w equals 60, some algebra. W equals x is corresponding angles. Transitive property gives us this. X and 3y plus 6 is corresponding angles. Transitive property to get rid of the variable. And algebra gets us to y equals 18. Now here's your essential question. Feel free to pause it and take time to fill out all 6 of those reasons. Example here, we talk about find the values x, y, and z. Well, x and 110, they're CIAs, so x equals 70. And then here we got corresponding angles, so we can use the transitive property to solve for y. And then the z right here is corresponding angles again, and we use some algebra to solve for z. And that is a little rundown on what you've got. I think I've got like 15 seconds or so. Yeah, there's your 6 reasons right there. Those are the only ways to prove 2 lines are parallel for the course of this class. Fill out your summary, fill out your notes, make sure you get your homework and everything ready to go for class, and